My screen is visible, right?
Yes, sir.
So today we will walk through Kubernetes self-hosted Kubernetes cluster. Okay. So what is a self-hosted Kubernetes cluster? Anyone?
Kubernetes cluster, which is managed by us completely.
Yes, you're right, right. So coming to self-hosted, we are the one who need to install every part of this Kubernetes. Every part in the sense of master part and worker. So we need to choose the corresponding machine that we need to install the master part. Then we need to configure the worker machines. After that, we need to join the worker with the master part. And there are several steps are there, okay, to creating a Kubernetes cluster in self-hosted way. So coming to EKS or any other managed Kubernetes, we didn't bother about these things, okay, because that cloud provider will set up all the things and they will deliver the Kubernetes to us. If we go with the self-managed one, sorry, yeah, managed one. So today we will go through how to configure a self-hosted Kubernetes cluster within our we can choose some machines, okay, for doing this. So we can configure self-hosted using Ubuntu machines. So what will we do? We configure or we selecting some Ubuntu configuration machines. At least we need two machines, okay? Two machines. One machine for master and the second machine worker. If we configure like 3, 4, 5, then that machine we can add as our worker machine, okay? So today lab we will configure at least one machine and we will add that machine to our master part. So how to fulfill this task? We need to configure some uh, before jumping or before installing the components or that services within these machines. Before we need to configure something. First thing we need to opening some ports, okay, in each of these machine, like master machine and worker machine. That port is for communicating with the different services are running, right? So each services communicate with the different ports number. So we need to open when configuring machines, okay? For example, when configuring the worker machine or master machine, we need to open corresponding ports within the EC2 level. Then coming to worker machines, we need to open some other ports, okay? So there is a communication between these worker machine and master machine. So these communications via ports. So we need to open the corresponding ports. So what are the ports for master? For master part, we need to open seven seven ports. Okay, seven ports in the sense of first we need to open port number 6443. That is for Kubernetes API server communication. Then we need to open 2337 to 2380. This range port we open for communicate with the ECTD server client API. Okay. These are the components within the master part. Similar way, we will open port number 10250, 10259. These are the ports. There will be some echoes. I will show you the ports details. Okay. Hmm. Can you see my screen? Hope it's visible, right? The ports.
Yes.
Yeah. So see here, first we will open TCP 6443. That is these ports for the master part and the below for the worker part. Okay. So coming to master machine, okay, when we configure the master machine, uh, at the time of installation or we will create a separate security group and we need to attach that security group within the master machine. So ensure that we need to open or we open these ports, okay? Like first one for the Kubernetes API server, second one for etcd server client API, then kubelet API, kube scheduler, kube controller, remote access with that specified machine. Okay, then we need to open the 22 port. Then UDP 8472. That's for cluster wide network communication flannel. Okay, this is a service for internal network communication. Okay, like network policies. Then coming to master worker part, we'll open kubelet API, same port for communicate with the master and worker. Then TCP 30,000 to 32,767. Okay. These ports we open around 2000 something port here. Okay. So these ports were not port services. Okay. So that this means uh, these ports are we using for accessing our application. Like around 2000 ports are opening for accessing our application via not port service. Okay. This is a service actually. The three service we learned, right? That cluster IP, not port, and load balancer. Then 32 for accessing machine and UDP cluster. This is for last one for internal communication, network communication. So we will add or we will open that ports before configuring Kubernetes. So here when coming to Kubernetes creation, okay, we need to use some services, okay, for configuring our Kubernetes cluster in self-hosted way. So in this lab, we will use kubeadm. Kubeadm service for set up our Kubernetes within our Ubuntu machines. Okay. So there are a lot of services are there. When, for example, you can choose any of the services before configuring Kubernetes. Okay, at least we need to take the help of these services. In this case, the common tool called kubeadm. Okay, so we can go to the lab, right? All of you. Okay. Is anyone tried to install Kubernetes managed one or Minikube? I thought after this section I will share the task, okay, for creation of these three Kubernetes services.
Sir, your voice is your voice.
Breaking, right?
You're not audible, Rafi.
Okay, give me a second. Now it's audible, right?
You're not audible.
Now it's audible. Stable, right? Now it's stable. You don't
Yes,
confirm?
sir.
Okay, fine, fine. Okay. My voice is stable, right?
Yes, sir.
Okay. So first we need to go to configure the machines. Okay. So in this case, I'm going to configure two machines. One is for the master and second mission for the worker machine. So master, I'm going with Ubuntu. Ubuntu version 22 is fine. And I change the machine type from T2 micro to T2 medium because this is a minimal version, like one virtual CPU only. So for running a Kubernetes cluster, I think we need uh, at least T2 medium. Okay, that comes with the two virtual CPU and 4 GB RAM. Well, fine. So coming to the security group, okay. See, by default, it's only open port number 22. That is also such. So, so what I'm doing here, I'm just going to. I think I added that security group, security ports. I mean, open that port using a security group before. So I will check that. Let's go to security. See, you can see my security groups window, right? So here I already opened, I mean, already I have a security group that is, I mean, opening some ports. Okay, that ports I opened for the security group. And I think one for the worker as well. Yeah. So worker node, I have one security group. So when coming to the security group, okay, this way we can create security group and open ports. Then we can attach this security group to the machine. That's fine. Two way we can attaching the security group. Okay. So here you can see I opened the same port number here, like 6443 opened, 8472 opened, and this 10,000 to 57, 250. Then some port ranges from 2003 to 380. Then the last port number 10259. So these are the ports I opened. So what I'm doing here, I just came to security group. Okay, create security group and name it the security group like master or worker. Then selecting the VPC, which VPC that we are using for the EC2 machine. Then here you open the port number like TCP port number. The port range 10734. This is example, okay. Then accessing, you can access like, then save. The next one is some ranges are there, some cases, okay. For example, you can see here like um 30 to 30,000 to 32,000 something, okay. So that we can add here 30,000 to 32,700. This way we can add. So what will happen? These all the ports are open, like around 2,000, 32,000, 30,000 to 32,700. In between, around 2,700 ports are there. So that all the ports open for that specific machine. After that, I will click create security group. Okay. Then what will how we will attach this security group when installing this way? Okay, like here we can see when configuring the EC2 machine, then coming to the security or firewall. In this case, it will automatically create a security group that name is launch wizard 45. That is only enabled the port number 22. So in this case, we need to choose select existing security group instead of creating new one and drop down our security groups. All the security groups will list here. Okay, so we need to select that mission. So select that security group. That's fine. So my case security group. Sound. The this security group is not listed here. That because of it's belongs to some other network. Okay, like some other VPC. That's why it's not listed there. So FD, I will check the FD which on that. Okay, this is the one I think. Hmm. Okay, now I changed my VPC where my that existing security groups belongs. Only that it will list here. Okay. Yeah, now it's listed. See the one for the master node. See the group name one. So I'm choosing the one.
Sir, you are not audible, sir.
Now
You
it's
are
stable,
not
right?
audible, sir.
What about now? Now it's stable. I placed my network.
Yes, sir.
Now it's stable, right? Okay, this part is fine. All of you selecting the security group. All clear? Okay.
Yes, sir.
Okay, fine. Then I'm going to create machine. Okay, the master machine. So the same way I'm going to create one more machine that is for the worker. Ubuntu. So coming to the worker part security group, I have existing security group. That group I added that required ports. Okay, I mean open the required ports. So that comes with the two. I mean the name. Yeah. So I am selecting the security group two. That's fine. I'm launching. Okay, both are running. Okay, fine. So I'm going to connect my machine, worker machine. So I'm changing my host name, okay? Host name. This is a command line tool to changing our host name. So host name, CTL space, host name, then the desired host name, okay? Host name. So this will be my master. So this is worker machine, right? Okay. Don't confuse our worker machine and master machine, okay? Because that port number is different when coming to worker and master. Some one or two port is common for each. Then yes. See, now the name is changed, routed to worker. Similar way, I'm going to connect my master node. Okay, connect. Similar way, I'm going to change the host name. Master. Then name.
There is a spelling
Yes.
issues in it.
Okay. Now it's done. So master machine and worker both are running here. So next thing is we need to perform some commands. We need to download some packages uh, in our master machine. After that, we will master and worker machine. Okay. After that, we will get a command to join to the master. Okay. So we need to perform this step by step, or we can use that scripting. Okay, like bash script. So it will execute all the commands. So in this case, we are going to create a like a shell script. Okay. So I'm first using a file nano common.sh. Hit enter. Okay. So so here we can add the command. Okay, the command that we can use manually, or if there is no lot of commands. Okay, so then we can use a script file and we can add the enter commands in this script file, and we can just run the script. That's enough. Instead of typing each commands and downloading the components or changing the configuration. That's why we creating the shells or bash when coming to production, because for example, we need to configure 10 Kubernetes cluster. Okay, so we need to perform the same commands in all the machines. So if we have a script file, then it's simple. Like we can just run the script file in all the machines. So these are the commands that we need to perform. So I added all the commands in this common.sh file. Okay. So see, we need to disable swap memory in this EC2 machine. Okay. So first sudo swap off. Then we need to create a file .config file and load the modules at the boot up. So these are the commands that we included for this load boot up module. Then systemctl parameters by setup, persist across reboot. So this is bridge actually, that internal network communication. So bridge in the sense of like the IPs, the IP versions, everything mentioned in this these commands. Okay, from here to here. Then here you can see like CRIO runtime. That is for the Dockers. Okay. Now we are going to perform a Kubernetes, right? So coming to Kubernetes, we are going to run containers, pod, and everything. So we need to run a runtime like Docker or CRI. In this case, we are going to use CRIO runtime. Okay. So it will download from that directory. Everything is mentioned. See the path URL. Then after downloading, we need to install. So here sudo apt update y apt update install CRIO. Then checking the services using systemctl commands like daemon reload, enable CRI, and start the service CRIO dot service. Then the next thing is add Kubernetes apt repository. And this is for kubectl command installation and everything. Kubeadm installation, sorry. Update yjq. Start kubelet. Yes. So these are the configuration commands that we need to perform. The master, these commands we need to perform in each machines. Okay. For example, the worker machine and the master machine. That's why I created the file name called common.sh. So what will I am going to save and exit it. And so how to run this this common.sh file. This is actually a script file. Okay. When we are naming conversion is .sh, that means it's a script file. So executing a script file like dot forward slash, then the file name common.sh. So it will execute. So here we can see permission denied. So whenever we need to execute something in file or anything, we need to first change the permission, right? So how how to give the executable permission for a file in Linux using change modification command, change mode, how given the executable permission. So plus x. So this will makes the file executable. Then the file name common. I will show you. Now you see the file name is not executable. I'm changing to executable. Chmod plus x. Then the file name. .sh. Now it's executable. Just I'm checking again. Let's see. Now the color is changed. So I'm going to run the file. So whenever run the file, that means what are the commands within the file will automatically execute, like downloading the package, installing package, everything it will manage. .sh. See, so it will go through the first command to the last, like downloading components, installing, verifying, enabling. Yeah, everything will happen here. So the same time we can go to the second machine, that is our worker machine, and here we can create a same file, common.sh, hit enter and paste the commands. Save it. So the coming to master is done. So yes, I run on worker machine as well. Anyone have a doubt as of now? When coming to lab, I will share the enter commands. Okay, so you can perform with your own environment. So both done. Okay, the common installation on each machine has been done. So we need to perform some more commands only on the master now. Okay. So now I am switching to master machine, and here we need to perform some additional commands. So that is pulling some files from our like repository. Okay. So that's for kubeadm configuration. So here what will happen? It will download. Falling back to stable. Yes, it's pulling the images from internet. This is the part of kubeadm configuration. Okay, because here we are going to use kubeadm for setting our entire Kubernetes cluster. So now I am here. I download the packages using kubeadm config image pull. So it's image pulled and saved in my local machine. Now I am going to initiate the kubeadm here. So kubeadm init command I performed. Okay, that's fine. Now I need to perform one more command. That command is going to create a directory home.kube. Then it's copying some files from this directory to a different directory. Then change the ownership. Okay. So hit enter. That's fine. Hmm. When coming to Kubernetes, we need to, by default, there is no network policy within the Kubernetes cluster. Okay. So we can add network policy. Network policy means it's a, like a, it's an internal network communication. Okay. Like, for example, in our Kubernetes cluster, there is a lot of pods are running, right? So we can manage the pods using network policy, okay, after enabling that thing. So there are some network policy agents are there, like Calico, Flannel. So in this case, I am going to install a network policy that is Calico. So that is done. Then seems our cluster is ready, up and ready. Okay. So one more thing I need to do, like we need the uh, joining command. Okay. Now I am in the master machine. So the master machine gives the joining commands. So after getting the join command, we can paste the join command with our desired worker nodes. So copy that join command and paste it on the worker node. So it will uh, the node machine added to the worker part. So now it's fine. I can check kubectl get node. See, now the Kubernetes is running fine. Kubectl get node. So it will show the node. Okay, only the master node are running here. That is the role is control plane. Control plane means the master part. Okay. So now I am going to getting the join command. Okay. So this is a command kubeadm. We are talking with kubeadm token create and join command. So it will create a join command. So this is the command. So copy and go to the the worker machine. Now here you can see only one node is running here there. The one node means the master, okay. So I'm pasting on master machine the join command. So hit enter. So now it's trying to connect with the master, okay. So we can go here and check it again. Kubectl get node. See the worker listed here. Before only master is showing. Now you can see the worker successfully added. So this is the way we creating self-hosted Kubernetes cluster and adding the machines. For example, if you need one more node, what we'll do? We need to go to here. We need to create another machine, then running the common script that into that worker machine. After that, copy. Generate that join token and paste it on that newly mission. So that mission will add it here. So we can see when kubectl get node, that mission will listed here. Kubectl get pod. It not showing anything because no ports are there. Then checking the namespace ns. So default and the namespace listed here, and these are the common namespace for running the master node configurations or services. I'm going to create one namespace kubectl create namespace, then the name of the namespace, Apple. See, namespace Apple created. Can check it. See the Apple is listed here. Now we can deploy application like similar way, like before we done in like managers Kubernetes. So this is similar Kubernetes service, but when coming to like complex application deployment within the self-host Kubernetes cluster, we need to configure the load balancer as well. Okay, so manually we need to create the load balancer because when coming to EKS, okay, so when coming to EKS, we just expose any service type is equal to load balancer. So the cloud provider will automatically create a load balancer for us because it's a managed one. So coming to self-hosted, we need to create the load balancer and configure the load balancer. So that's the only thing I notice when coming to self-hosted and managed one. So now we can just try to deploy something like kubectl create. We can go with some like not declarative. Okay, this is not declarative. This is imperative way of uh, application deployment. Okay. Deployment. We can deploy a Nginx web server. Okay, within our Kubernetes. So we need to first we need to give the name, the Nginx, then the image name. Image name, I will check image name. Image is equal to Nginx. That's a common name. So this will download the Nginx from Docker Hub. Okay, this is download when this is actually creating a Kubernetes kind deployment, and the deployment name is Nginx. Then the image, we need to mention the dash dash image is equal to Nginx. That means a Nginx name, a unique name image belongs to Docker Hub. Okay. So it will download or it will pull the image from the Docker Hub and run it on our Kubernetes cluster under the deployment Nginx. Got it. Here we already created a namespace Apple. So how to pointing to that namespace dash n then Apple. So this deployment under the namespace Apple. Otherwise, it goes to the default one. So it done. See, deployment.application Nginx created. Now we can check the pod kubectl get pod. We need to mention the namespace as well in Apple. See, Nginx one by one running. So this way we can download or pulling the image and running in our given cluster. Deployment. Okay. So anyone have any doubt? All of you. I'm audible, right?
Yes, sir.
Okay. Anyone have any doubt on the self-hosted Kubernetes?
No, sir.
What about others? My
Uh, no doubts now, sir. Only probably when we work on it, we will be having more clarity.
then shall I send the task for each like self-hosted, managed, and minikube?
Okay,
Can
sir.
you all try
Sure, sir.
along with the code?
Okay,
Yes, sir.
sir. Yes, sir.
Okay.
Sir, please do send the commands as well.
Yes, yes.
Okay, sir. Thank you.
All are good, right?
Yes, sir.
Okay.
So far, yes, sir.
Okay, okay. Then I will create the task and send to you, okay, within couple of minutes. Then
Sure,
we
sir.
can wind up, right?
Sure.
Okay. Okay then. Bye all. We'll meet
Bye,
tomorrow,
everyone.
okay? Yeah.
Yeah.
Thank
See you
you, sir.
tomorrow.